is known as omega-3. They play a role in nervous system function, among other things. So it's one of those things, if you want an extra mark here and there, you want to gamble on it, go ahead and read about them, but I'm not going to bet too much on them. On B.4.5, you're supposed to know something called the iodine number. Okay, well, iodine number is the number grams of iodine per 100 grams of fat. So let me do some explaining here. And oh, by the way, while I'm looking this up, a lot of these features that I'm talking about are on that study guide that was sent to you, or excuse me, that was copied from that book. You'll see them on the website. So similar to bromination, if you remember, bromination was a test for alkenes. This is exactly the same. Iodine, which is also colored, iodine will add to a double bond, just like bromine will. So if this is our alkene, and if we were to add iodine to this, it would add across that bond. You'd have an iodine, oops, that should be an I. You'd have an I added to each of these, did it again, to each of these carbons. So this is a method for determining how many double bonds are present. So for a little bit of instruction, suppose you had 1 mole of a fat, or fatty acid. We'll just say fatty acid, that's the long chain thing. And that fatty acid had 1 double bond. Then there is 1 mole of those double bonds. So if you added iodine to it, 1 mole of iodine would react. So for each double bond, it consumes 1 molecule of iodine. So this is a method for determining how many double bonds are present. If you have a fatty acid and it requires 2 moles of iodine to completely react with 1 mole of the fatty acid, you know that the ratio of double bonds to fatty acid is 2 to 1, and so on. So from those molar values, you can easily convert to gram values. So once you know moles of iodine, you can convert to grams of iodine, and typically you're given the moles of fat and its molar mass, which you can figure out from the formula. So that would give you the grams of fat and the grams of iodine, so you could calculate this ratio. Remember, iodine number is defined as the grams of iodine per 100 grams of fat. So you could do a ratio where this answer go on top, this answer on bottom, equal to this ratio. So whatever those two numbers are, multiplied by 100, that'll solve for this. Okay, that's what the iodine number is. B.4.6 talks about this, the condensation of triglycerides. So write that note to you there. B.4.7 is the digestion of fats. I'm not going to spend much time on that, if any. You can read that on your own, and I did talk about the high energy content because of the lack of oxygen. The carbon to carbon, carbon to hydrogen bonds are efficient at energy storage. They release quite a bit of energy. There's no oxygen present, or very few. And the last point in lipids is B.4.9, which is the major functions. So refer to the chem guide. There are quite a few. If you're asked to label them, it'd probably be 1 or 2, and so you can just look at that list right before the test and be ready to write them down. So at this time, that's a real basic intro to option B. The most difficult parts will be the separation of the proteins, the carbohydrate rings and the polysaccharides and disaccharides. Those are the most difficult parts of that. Lipids tend to be fairly simple. You need to learn with lipids how to read the data book and how to read condensed structural formulas. They're probably going to ask you an iodine number problem and what unsaturated and saturated means. For the remaining things, which are B5, those are micro and macronutrients, B6 hormones, honestly, read the chem guide. That's the curriculum. That's one of those issues where the teacher notes part, which is that curriculum. Remember, it was designed, it has these boxes, and it has this like B5.1 here. Over here are notes. The answers are over here. 9 times out of 10 for both of these sections, for a lot of these sections. For example, micronutrients, it just basically says you need to know the difference, and it does tell you the difference. It gives you an example of a few of them, and it tells you, you know, if you're missing them, what's going to happen. One thing I will say in B5, it wants you to know how to tell between water and fat-soluble vitamins. Remember, a lot of OH groups, water-soluble. No OH, fat-soluble, because this is polar, like dissolves like. Non-polar, like dissolves like. Water-soluble vitamins are vitamins B and C. The structures of them should be in the data book, so you should see the hydroxyl groups. And the fat-soluble are A, D, E, and K. Again, in the data book. I think that's about it. So remember, you can't do too much. There's going to be questions you don't know. Don't give up. And hopefully if you see this video tonight, you get a chance to look at some of the material. And I'd love to hear about it after your test. So good luck, everybody. And get a good night's sleep, too.